Ladies and gentlemen, this is a recording of section 3.4. Section 3.4 is all about zeros of polynomial functions. This is a section that I would pay extreme attention to, because this is a section that is definitely on the SAT. And so here we go. So what is the zero of a polynomial function? And in essence, it's anything that will translate to where any result of that value will equal a zero as a solution to the equation. So for example, in example 1, they're asking you to use what's called the rational zero theorem. And the rational zero theorem in this example, basically they give you f of x is equal to negative x to the fourth plus 3x squared plus 4. The way this translates is we're going to look at the constants they're involved in the factors of the constant. So 1 times 4 is a factor of this constant, and so is 2 times 2. If you look at the factors of the leading coefficient, basically we have plus 1 minus 1. So as we list these factors, we would then list them as possible. That doesn't necessarily mean that it is a zero, but possible rational zeros of this function will basically be written as the fraction. So notice that I'm going to write plus and minus 1, plus and minus 2, and plus and minus 4. And that's these values, these factors of the constant over the factors of the leading coefficient, which in this case are simply plus and minus 1, which are these guys here. So these are these values. Okay, so now listing them, what you would want to do is just that. Basically, the list in this case would simply be plus or minus 1 are possible rational zeros, plus or minus 2, and plus or minus 4. Let's do another example. So actually, let me give you the try for example 1. I'll list it here. So the question stem says list all possible rational zeros, and then they give you the polynomial, which in this case is f of x is equal to x to the third power plus 2x to the second power minus 5x minus 6. So once again, to list them, and if you want to do this on your own and check the answer, you can. Just pause it here at this point before I continue, and then check back. So step 1, we're going to list the constants. So plus or minus 1 times plus or minus 6, plus or minus 2, and plus or minus 3. So these are the factors of the constant. Want to do the same thing for the coefficient. So we know obviously this will be plus or minus 1. So same process, we list plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6, and all of those over plus or minus 1. So the list for the possible zeros is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. That's all you have to do. So these are numbers that potentially, when you substitute them in, you can actually solve. So let me go back, actually. Let's go back to the original one that we did, which was negative x to the fourth plus 3x squared plus 4. And so let's use Desmos. Desmos is a wonderful tool. And I'm going to literally just post this here. So f of x is equal to negative x to the fourth. And this is plus 3x raised to the second. And there you go. You get this funny looking graph. We're looking for the zeros. Now, for it to be a zero, it has to be on the x-axis. And so if you take a look at this, I'm missing something. 3x squared, oh, plus 4. I knew I was missing something. Again, those are your values there. Do you notice that this simply goes through those 2 points on the x-axis? And that is your actual set of zeros. So if I'm looking for the zeros, it's the actual zeros, that would be plus or minus 2 for the x. And that obviously would be a 0. So on the ACT and SAT, this is a typical question they would ask you. They would give you a diagram and they would just say, can you list the zeros of the equation? And so in this case, you would just simply select A, B, C, D, E from their answer choices. And obviously you would want the negative 2, 0, and 2, 0. If I did the same thing for the prior example, let me go to this one. And let's plug in the one we just did. Our try question, which was positive x raised to the third and plus 2x squared. Okay, and negative 5x and negative 6. See how we get this diagram? Okay, and in this diagram, you can see your zeros are negative 3, 0, negative 1, 0, and 2, 0. So you actually have three zeros in this equation. You also know that because it's intersecting the x-axis 3 times. You also know that it's going to be at least 1, 2, 3 because of the fact that you have more than that in terms of zeros. So, little hint. Okay, so here we're just listing, again, in this one, they just wanted you to list it. They didn't want you to solve it, but we did just solve it just by looking at the graph. All right, let's look at example 2. In example 2, we're going to do the same thing, but this time, what changes a little bit, so we're going to use the rational theorem. So it's actually the rational zero theorem. Rational zero theorem. Okay, so rational zero theorem, we're going to list all possible rational zeros. So let me write that down because I don't want you to forget. So you're going to list all possible rational zeros of the equation where we have, or of the function where we have f of x is equal to 15x cubed plus 14x squared minus 3x minus 2. So once again, we begin with that process. So we'll begin with listing the constant because that goes first. It's constant the zeros of the constant, or the factors of the constant. Let me write it up here for you. Factors of the constant and the factors and the factors of the leading coefficient. Okay, so factors of the constant, obviously plus and minus 1, plus and minus 2. And the factors of our leading coefficient, we have 1 times 15, plus and minus, of course. And then plus and minus 3, and plus and minus 5. All right, and now we write them in that same top to bottom order. So we'll start with plus and minus 1, and plus and minus 2. And all of this is over plus and minus 1, plus and minus 3, plus and minus 5, and plus and minus 15. Now, you notice here you're going to end up with several fractions. So we start with 1 over each of these, respectively. So I'm going to end up with plus and minus 1 over plus and minus 1. You have plus and minus 1 over plus and minus 3. You have plus and minus 1 over plus and minus 5. Each of these obviously resulting in at least 2 to 3 or possibly 4 possible categories. And then plus and minus 1 over plus and minus 15. And from this, we then continue with the 2. So plus and minus 2 over plus and minus 1. Plus and minus 2 over plus and minus 3. Plus and minus 2 over plus and minus 5, and then plus and minus 2 over plus and minus 15. And then from this, once we divide, remember the negatives cancel, the positives also stay positive, but when you have plus and minus, you end up with plus and minus of each, respectively. And so once you simplify all of the possible duplications and get them out of the way, your final answer here will end up being plus and minus 1, plus and minus 2, plus and minus 1/3, plus and minus 2/3. Don't forget to simplify some of the fractions. Plus and minus 1/5, plus and minus 2/5, plus and minus 1/15, and plus and minus 2/15. And so that means that there are 16 possible zeros of the equation. Having known that, you then try and test them. So when you actually throw them into the equation, we could try, for example, if we have, okay, so let's see if we can use simplifying. Let me see, 14x squared minus 3x minus 2. So I want to check to see if maybe, if I do factor by grouping as an example. So let's pull out the x squared. I doubt it. This is going to give me 15x plus 14. And that's not looking hopeful. So factor by grouping is not something I can use. What you would do now, if you're actually trying to solve, you can graph it. So let's go ahead and graph it first and see what we see. Maybe it'll be obvious to us. So we have 15x raised to the third plus 14x raised to the second. That would be 14. Let me go back. Minus the 3x. Okay, and then this ends with a 2. So minus 2. All right, well, I do see 3 zeros right there. Boom, boom, boom. So you can see that then 0.333, we know that's 1/3, right? It's got to be a negative 1/3 and a positive 2/5. And then we also have the negative 1. So we know that negative 1 is one of the zeros. So let's play with this information. I'm going to take that negative 1, 0, and we're going to use that. So I want you to notice that on the graph, and I want you to make this connection, please. So on the graph, we saw negative 1, 0 as one of the zeros of the equation. We saw negative 1/3 0 as the second one. And we saw 2/5 0 as another one of the parts of the equation. So let's test this theory with division. You did learn division. We did talk about division. Let's use it. So if I use synthetic division, which is super quick, I'm going to use the negative 1, and I'm going to show you a little trick here, or make a connection at least. Notice these coefficients, and I'm taking their signs. So I have 15 that's coming from here. I have 14 that's coming from here, and so on, right? So I'm just highlighting them so you see that I did take the sign with the actual value, the negative 2, and so on. Okay, so drop to 15. Negative 1 times 15 is negative 15. Looks like that leaves me a negative 1. Negative 1 times negative 1 is positive 1. Negative 3 plus 1 is negative 2. Okay, and negative 1 times negative 2 is positive 2. And you notice that I get a 0 remainder. That right here, this is how you know that that is a 0 of the equation. In this particular case, we use negative 1 because we have negative 1, 0. Okay, now, why did I do this? Because now, remember this was originally an x to the third, but no longer. And so what we have here is negative x to the second power, I'm sorry, to the first power. So you have negative x these should all drop 1 sign. So this originally is x to the third. This is now x to the second. This originally was x squared. This is now just x. So I'm using negative 1x. And then this will be just negative 2 because this was originally an x. Now it's an x0, which is a constant. Okay? So remember that. And this is now your remainder, which is 0. So x minus 2 is your remainder. And that is the function that we're working with. And so now we would need to use that to substitute and solve. Okay, with that said, if we do the 1/3 instead, let's say I start with a negative 1/3, and I divide this into the original 15, 14, negative 2, negative 3, negative 2. Again, you drop the 15, you simply drop it when you start. And here we always multiply. So negative 1/3 of 15 is negative 5. So because 3 goes into 15, 5 times negative 1 is negative 5. Okay, so at this point, 14 minus 5 is going to leave you 9. Negative 1/3 of 9 is simply going to give you negative 3. The result here is negative 6, and negative times negative is a positive, and 3 goes to the 6, positive 2 times. leaving you a remainder of 0. Hence, another proof that this is a 0 of the equation. And so in this case, again, remember this was originally x cubed. This is now 0x squared. This is 9x, this is minus 6, and then obviously the remainder. So you're left with 9x minus 6 in this case. If you set that to 0, you would get 9x is equal to 6, which if we divide by 3 on both by 9, oh sorry, this is 9x, so we divide by 9 on both sides, this will cancel and you will get x equals 3/2, or 2/3, I'm sorry, 2/3. It's opposite. You can continue doing the rest and so on. And so same thing here for the 2/5, you would just simply divide and you would prove that this was a 0 of the equation the long way. This is a very long way. All right, so that's how you prove that these are zeros. If you wish to try this, here's the try. So it's simply pause this once I'm done writing. List all possible zeros given f of x is equal to 4x to the 5th plus 12x to the 4th minus x minus 3. All right, go ahead, pause it, give it a try, and when you're done, remember this is just a list. This is not the actual zeros that I just modeled. We're just listing. Your list should be plus or minus 1, plus or minus 3, plus or minus 1/2, plus or minus 1/4, plus or minus 3/2, and lastly, plus or minus 3/4. All right, example 3. Now we're going to find, so it's finding, not listing, finding zeros of a polynomial function. And so this question stem says find. Yes. Find all zeros of f of x equal to x cubed plus 2x squared minus 5x minus 6 Okay, so again, once again, we're going to do the same thing we just did prior, and so we're going to list them first. So the list, we're going to find the factors of the leading coefficient and of the constant, and you should end up with the following list. So the list begins with plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And now we're going to divide. And so I'm going to start with a possible 0. I'm going to start with 1. And if I divide 1 using the coefficients, which are initially 1, 2, -5, -6, and notice that I'm also looking at this exponent, making sure that these are in descending order. So if I drop the 1, 1 times 1 is 1, 2 and 1 is 3, 1 times 3 is 3, minus 5 and 3 is -2, 1 times -2 is -2, leaving me a -8. So because I have a value in the remainder column, this is not a 0. Am I clear on that? I'm trying to make that point crystal clear. Repeat the process, and now we'll use the 2. Obviously, we're going to use -1. You wouldn't have known that, but I'm telling you, -1 is not a 0 either. So let's try 2. So 1, 2, -5, -6. So we'll drop the 1. 2 times 1, that's going to give you a 2. So we have 4. We have 1, 4. This is dropped. 1, 4. 2 times 4, 8. -5 and 8 is 3. 2 times 3 is 6. No remainder. So therefore, this is a 0. This is a 0. And you know that because of that. Now, you do notice that we end up with, if you remember, this was x cubed. In this case, we have 1x squared. We have a positive 4x, and we have a positive 3. And obviously no remainder. The question is, can I factor this? And the answer is yes, you can factor this. It would need an x and an x. I would need a +1 and a +4. I take that back, +3. A +3. And those are the possible remaining factors. So that means that x equal to 2 is a 0. -1 is a 0, and so is -3. And we get that from here. That's where these come from. All right. And so this is the solution set right here. Technically, we write these in order. So -3, -1, and 2. All right, let's do a try on this one. Let's try. In this case, we're going to find all zeros. And so they give us f of x is equal to x cubed plus 8x squared plus 11x and minus 20. And you will notice that technically you cannot use factor by grouping. So if you want to pause this, go ahead, pause it, find your solutions, and when you're done, come back and the solutions are here, where your solution set are x equals 5, -4, and 1, following the same steps as above. The only difference in example 4 is that we have to use the quadratic. So we're still finding zeros of the polynomial function in our polynomial function, where we have f of x is equal to x cubed plus 7x squared plus 11x minus 3. Now again, the difference in this one is simply the process. So the difference is you're going to use the quadratic formula. Again, another quadratic formula. All right, and if you don't remember the quadratic formula, I will remind you, negative b plus or minus the discriminant, which is b squared minus 4ac all over 2a. That's the only difference in this question, same process. So I'm going to leave this question for you to tackle using the same process. And in this one, if you want to pause it once I'm done, if you pause it right here, give it a few seconds or try to work on it, and then come back to this section. For this one, your final solution should be -3, -2 minus square root of 5, -2 plus square root of 5. And those are your zeros of the equation, because there are zeros that are irrational numbers. All right, let me give you the try part of this question. The try part of this question is find all zeros of, and they're giving you f of x is equal to x cubed plus x squared minus 5x minus 2. That's your question. Again, the only difference here is you're going to use a quadratic formula once you start dividing. So if you want to go ahead and work on it, pause it here, and once you come back, these are the solutions. So your solutions will be 2 comma -3 minus square root of 5 over 2, and -3 plus square root of 5 over 2. Super. All right, so let's look at another example. Here we're going to use the word root to reflect a 0. So this is example 5, where we are solving a polynomial equation heavily tested on the SAT, and a lot of you probably missed this stupid question because you weren't paying attention to the wording. Look at what it's saying. It's saying solve, and then it's giving you x to the 4th minus 6x squared minus 8x plus 24 equal to 0. Okay? And so the reason why we're using zeros or root instead of 0 is because once we solve for this, we're actually looking at properties of roots. And in this case, because we're using the word root, we're dealing with I. Remember, I is equal to the square root of -1. And so that is an important realization, that now we have those negative numbers coming into play. The process is the same. We're still finding the factors of the leading coefficient and the factors of the constant. And in this one, 24 has a lot of factors. So we're going to end up in this case with plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 4, plus and minus 6, plus and minus 8, plus and minus 12, and plus and minus 24. So this is the list of zeros. So for the sake of not having you get stuck in solving for zeros with plus or minus 1, I'm going to start you with 2, because 2 is a 0. And I only know this because I've been doing this for 25 years. So anyway, so I'm going to start you with the 2. We're going to start with the coefficients of the equation, which are simply listed right here, right? We're going to use these numbers. All right, and remember that I have to follow the exponent order. So yes, I'm going to start with 1, but notice that I'm not going to put in -6 yet. I'm putting in a 0, because this is the x to the 4, this is the x to the 3, which is missing. The x to the 2 happens to be the -6, then -8, and then 24. And so those are my factors that I'm going to use, my powers, right? So 4, 3, 2, 1, 0. So we drop the 1. 2 times 1 is 2. 0 plus 2 is 2. 2 and 2 is 4. -6 and 4 is -2. 2 times -2 is going to give me -4, which added together with the -8 is -12. And then 2 times -12 is -24. Hey, look, it's a 0. So this is one of my zeros of the equation. But that means that I am now left with, in this case, let me see, I have 1, 2, -2, -12. So this would be x to the third plus 2x to the second minus 2x minus 12. And obviously equal to 0. Because remember, this drops from x to the 4, it drops to x to the 3, and so on. Right? All right, so now we're here. And I know that I have x minus 2 as one of my factors. I know that because I'm looking at it right here. It's always the opposite in factor form. So if I try the 2 again, which I am going to try again, I'm going to divide the 2. Notice that I'm using my coefficients 1, 2, -2, -12. And do the math. Drop the 1. 2 times 1 is 2. 2 and 2 is 4. 2 times 4 is 8. 8 minus 2 is 6. 2 times 6 is positive 12, which gives me a 0. Okay, remember, we started with this one. Initially, this is now x3, which means that this is x2. So I have x squared plus 4x plus 6, and then obviously equal to 0. At this stage, I know I have at least 2 factors. So I have x minus 2. I have x minus 2. Okay. And I have what's left over, which is my x squared plus 4x plus 6. Can you think of factors that would help me solve this? And in this case, we're left with this prime trinomial. So if we use the quadratic, and when we're done solving this, this one results in -2 plus and minus I squared of 2. And so our factors are positive 2, because remember this is plus and minus of that. So this will be 2, comma, -2 minus I squared of 2, comma, -2 plus I squared of 2. And those are my factors of this equation. A little bit more involved, you just have to think it through. So if you wish to stop the video, I would like for you to try this one. And once you're done with this, I'll give you the answer after you've tried this. That's 13 equals to 0. Let me rewrite that. Just make sure you understand that that's a 13. All right, so go ahead, pause the video, and the solution to this is going to be 1, comma, 2 minus 3i, comma, 2 plus the 3i. Remember, you always have to have that conjugate. All right, I have the last 2 concepts. So this one is, again, one of those concepts that you might be missing on the SAT. So I'm going to try to drive it home. The concept is basically the fundamental theorem of algebra. The fundamental theorem of algebra, in essence, says that if f of x, a function, is a polynomial of degree n, where n is greater than or equal to 1, then the equation f of x equals 0 has at least one complex root. All right, so what does that mean? It means that if you look at the concept of x minus c1, where c1 is one of the values as a root, and q1 x multiplied to 0. And so in this case, the degree, if the degree of q1x is at least 1, the equation q1x is equal to 0. All right, that sounds like hieroglyphics at this moment, doesn't it? But it just basically means that when you multiply things out, it'll result in 0. So let's look at the linear factorization and see if that'll help you understand this. So in example 6, they kind of clarify this a little bit more. So the question stem here says find a 4th degree polynomial. A 4th, my goodness gracious. A 4th degree polynomial function f of x with real coefficients I actually like to start teaching this part with this example and then go backwards. So let's pretend I never said what I said up there. Just focus on up here with me for a minute. So with real coefficients, -2, 2, and I, such that f of 3 is equal to -150. All right. So let's start with setting this up with the x minus c. Now you notice that they give you 1, 2, and then this one is 3 and 4. Please understand that this is always plus and minus. That's where the 4th one comes from. So we would begin by setting this up with f of x is equal to a sub n, which is some coefficient we're going to find, times x minus c1 times x minus c2 times x minus c3 times x minus c4. And so that's where we start. We already have c1, c2, c3, c4. Understand why I say that. Notice that I'm going to start with a sub n, parentheses x minus minus 2, x minus 2, x minus I, x minus I. And so simplified, this will give us a sub n, parentheses x plus 2, times x minus 2, times x plus 1, times x minus I, not 1, I, I'm sorry, x plus I, x minus I. And now we start to factor. So if I factor these two out first, I have a sub n times x squared minus 4. And if I factor these, I'm going to end up always with x squared plus 1. Always. This simplifies to a sub n, and if I factor all of these, I end up with x to the 4th minus 3x squared minus 4. Remember, this is f of x, but here's what we do know. We do know that this is really f of 3, which means a sub n, parentheses, 3 to the 4th minus 3 times 3 to the 2nd minus 4, which if I simplify this, this will be f of 3, which is equal to a sub n, parentheses 81 minus 27 minus 4. And according to our question, this was equivalent to a negative 150. So negative 150 is equal to a sub n times 50, which if I divide by 50 on both sides, that means a sub n is equal to negative 3. If I go back into my example, that means that this is f of x is equal to negative 3, parentheses, x to the 4th minus 3x squared minus 4. And that's the equivalent value of my f of x. If I distribute this 3, I land with f of x. Final answer is negative 3x to the 4th plus 9x squared plus 12. And that's my final answer. That's what was being stated up here in this part of the explanation. The fundamental theorem of algebra. When I start talking about the actual multiplication of the values as you're given the values. Now, the actual name of this is linear factorization. Linear factorization theorem. That's what we just did. Okay, this you can find on pages 401 and 402 of your textbook in case you want to read it and take it in for yourself. Now, the last part of this chapter, or the last section, is Descartes' rule of signs. Now, in Descartes' rule of signs, we're looking for sign changes. They are either positive sign changes or negative sign changes. Now, on page 403, if you wish to read the explanation, go ahead. I'm not going to do that because I don't want you to get confused. Because I feel that if you take it in for yourself, you'll be better served. So let me just give you some examples of how this works, and when we're in class together, we can discuss this. And so if I begin with example 7, and I sort of walk you through. We can discuss this in steps. So we're going to find the number of possible sign changes here, and so go from there using this example. So we're going to start with f of x is equal to x cubed plus 2x squared plus 5x plus 4. That's example 7. And so we're going to look for positive zeros, and we're looking for negative zeros. And I'm going to show you how to do that real easy of an equation. So if I begin with this example, from the first term to the second term, is there a sign change, yes or no? In this case, no. Is there a sign change from the second term to the third term? In this case, no. Is there a change from the third term to the fourth term? No. So in this case, we would argue that there are no positive zeros. So in this case, no positive zeros. More specifically, no positive real zeros. All right, having said that, what about the negative zeros? To find the negative zeros, we're going to substitute in negative x. So we're going to do f of negative x is equal to negative x cubed plus 2 times negative x squared plus 5 times negative x plus 4. All right, so when I work this out, I'm going to end up with negative x cubed. This is going to be positive 2x squared. This would be negative 5x plus 4. Now the question is, how many sign changes are there? So we're going to start with one sign change, because that goes from negative to positive. This goes from positive to negative, and this goes from negative to positive. So according to this, I should have 3 negative zeros, real zeros, or possibly 2. Actually 1. I'm sorry, just 1. This would be just 1, because the idea is you either have as many as you have, or you have 3 minus 2 of those, which would be 1. So you could have one real imaginary, or one real root, and the rest are imaginary, and so on. If I test this, having looked up the zeros, which are of this equation, the zeros or a list of zeros would be plus or minus 1, plus or minus 2, plus or minus 4, and all of this is over plus or minus 1, which means that the list of possible zeros is plus or minus 1, plus or minus 2, and plus or minus 4, which is fine because we could start with testing negative 1. If I test negative 1, I've got 1, 2, 5, and 4 from the original, right? 1, 2, 5, and 4. Which if I drop the 1, this is negative 1. So 1, negative 1 times 1, negative 1. 4, negative 1 times 4 is 4, negative 4, so that's a 0. So it looks like in this case, negative 1 is a value. So if that is the case, then that means that I have, in this case, this will be an x squared plus x plus 4. Obviously, there are no 2 values that are going to give me that, so I'm going to have to use the quadratic. Once you use the quadratic, you can, in this case, Let me see. So 1 root in this case is -1. So it's imaginary, right? And the other 2 roots are, I'm sorry, 1 actual root is -1. That's a real root. The other 2 are imaginary numbers in a conjugate pair. And you know that because if we use the quadratic formula, -b, so -1 plus or minus the square root of 1 squared minus 4 times 1, 4ac, 4 times 1 times 4, all of this divided by 2 times 1, you end up with -1 plus or minus the square root of 1, this would be 1 minus 16 over 2 times 1. So you could end up with -1 plus or minus the square root of -15 over 2. So conjugate pair, yeah. So that's what they're getting at in this case. If I give you another 3 examples, so let's do another 3 examples just to verify. These are positive, so I'm going to start with sign changes. And so this is just looking at positive real roots. So if I'm given f of x is equal to 4x to the 5th plus 2x to the 4th minus 3x squared plus x plus 5. So looking at this one, no sign change here, but there is one here, there is a sign change here, and that's it. So I've got 2 sign changes, so 2 possible real roots. All right, and if I use the second process, since it's 2, take away 2, the other possibility is no positive real roots. Okay, so the key is to not forget the yes, we're kind of going to count them. So this is where we get the 1 and the 2. But then the second step, which is where people forget, you always subtract 2 as a possibility, and that gives you your second selection of options. We can discuss this further in class, again, once I see you. If you're still stuck or office hours, just talk to me. All right, and this is your video for section 3.4.